A very good morning to all the distinguished guests, association members, and ladies and gentlemen. Good morning. It is my pleasure to be the host for the great webinar today. I am Rani on behalf of MAA. Would like to extend a very warm welcome to all of you to our second session of the Anatomy Research Network series. We are truly honored to welcome our MAA President, Associate Professor Dr. Siti Norma Hanim Hadi from USM, and our guest speaker today, Dr. Aspalilah Alias from USIM. Besides, we are also delighted to welcome all our mindful participants for taking your time off your busy schedules to join with us today. So as we all know, the aim of the Anatomy Research Network series is to provide monthly online webinar series opportunities to all the MAA members to share their accomplishment and their experiences in research and to expand their research networking and collaborations with the other MAA members. Okay, so without further ado, I would like to introduce our guest speaker today, Dr. Aspalilah Alias. Dr. Aspalilah Alias is an associate professor at the Department of Basic Sciences, Faculty of Dentistry, University Science Islam, Malaysia. She obtained a bachelor's degree in Doctor of Dental Surgery from USM, Master of Sciences in Anatomy, and Doctor of Philosophy in Forensic Anthropology from UKM. She is currently pursuing postdoctorate in Forensic and Odontology and Radiology in Leuven, Belgium. She has published 48 articles in index journals and 16 books. She also very active in writing in various newspapers and magazines. Her research focuses on geometric morphometric analysis, forensic anthropology, forensic odontology and radiology, bones, science and Islamic research, and also natural products. She has been honored with many prestigious awards, especially in Anugerah Pensyarah Cemerlang, Anugerah Buku Inovasi, Anugerah Penyelidik Harapan, Anugerah Buku Ilmiah Terbaik, Anugerah Penulis Prolific, Anugerah Penulis Versatile, Anugerah Buku Karya Asli, Anugerah Buku Suntikan, Anugerah Penulisan Popular, dan Lantikan Figura Sing. To top it all off, she also received many silver and gold awards in few innovation competition. It is our privilege to have you with us today, and without further ado, let us welcome Dr. Aspalilah Alias. The talk will be following by the Q&A sessions. Audience can put the questions in the chat box or can ask the questions at the end of the talk. Dr. Aspalilah?
Yeah. Can you see my slide? Right. Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alamin. Wassalatu wassalamu ala ashrafil anbiya'i wal mursalin. Wa ala alihi wa sahbihi ajma'in. Rabbi shrah li sadri wa yassir li amri wa hlul 'uqdatam min lisani yafqahu qawli. Yeah? Do you hear me? You hear me? اللهم افتح علينا حكمتك وانشر علينا من خزائن رحمتك يا أرحم الراحمين. السلام عليكم ورحمة الله وبركاته. And a very good morning.
Dr. Aspal, we can't hear you.
Can you hear me?
I can hear Dr. Aspa. It's clear. It's clear.
Clear? All right. Okay. Can I proceed? Okay. Today, thank you very much to the chairperson today, Ms. Rani, Associate Prof. Dr. Siti Norma, and all the committee members, ladies and gentlemen, for giving me opportunity to give a sharing session about my research project entitled Geometric Morphometry Analysis, a new method for analysis of human anatomical structure. Allah Subhanahu wa Ta'ala said in Surah Al-Mu'min ayat 12 to 14, A'udzu billahi minasyaitonir rajim. Bismillahirrahmanirrahim. Walaqad khalaqnal insana min sulalatin min tin, summa ja'alnahu nutfatan fi qararin makin, summa khalaqnan nutfata 'alaqah, fa khalaqnal 'alaqata mudghah, fa khalaqnal mudghata 'izama, فكسونا العظام لحمه ثم أنشأناه خلقا آخر فتبارك الله أحسن الخالقين. Allah Subhanahu wa Ta'ala said that human, sesungguhnya kami telah menciptakan manusia dari suatu saripati, iaitu tanah. Kemudian kami jadikan saripati itu air mani yang disimpan dalam tempat yang kukuh. Kemudian air mani itu kami jadikan segumpal darah. Lalu segumpal darah itu kami jadikan segumpal daging, dan segumpal daging itu kami jadikan tulang belulang. Lalu tulang belulang itu kami bungkus dengan daging. Kemudian kami jadikan dia makhluk yang berbentuk lain. Maha suci Allah. So human is created by very special. Each of us is different. Even we are twin, we are different from each other. So we come from the cells, and the cells form the tissue, and the tissue form an organ, and the organ form the systems. And we have many systems in our body. We have integumentary system, we have a skeletal system, endocrine system, cardiovascular system, nervous system, muscular system, and many other systems. But today I will focus to our skeletal system. So in our body, we have 206 bones. We have 206 bones. We have axial skeleton and also appendicular skeleton. In the axial skeleton, we have 80 bones in the spine, head, and also the chest. In the appendicular skeleton, we have 126 bones. So I want to focus on the skull. We have 22 bones. That means there are many things that we need to study in our bones. So the focus is on the forensic anthropology. Forensic anthropology is a field of the study which focuses on examination of bone systematically in order to get identification of remains in medical legal case. In the forensic, what happened is when the remains is destroyed and the soft tissue is decomposed, it's very difficult to identify a human, as our body destroyed in a few days. What remains is the bones. So in case of a mass disaster like tsunami, where the remains were massive, the process of the identification became complex and very difficult. Like tsunami, 100,000 or billion of people die in the same time. It's very difficult to us to see which is the bones it belongs to who. So the recent research focused on various skeletal elements to quantify variation related to sex, age, and race to facilitate forensic identification. So a great deal of research was conducted to identify shape and patterns of bone in human body. In some cases, the method able to describe size, but not to explain bone shape quantitatively. So besides, no study have yet quantify the morphology of bone comprehensively for identification purpose in Malaysian population. Thus, forensic anthropology is an application of physical anthropology, generally intended as a human osteology in forensic field. So in a mass disaster like tsunami or crime scene, we found unknown skeletal remains. So what we want to do is we want to know the personal identification. So the personal identification become complex, especially in her huge human remains. So this is for facilitated forensic identification. So what we can see from the bones, we can identify the sex, whether the bones belongs to male or female, whether the bones belongs to the children, the elderly, or whether the bone belongs to Chinese, Indians, or Malay, or what the stature, what the height of the person. So from this one, we can narrow down or helps the forensic field. So what I want to introduce is our geometric morphometric. It's a set of the statistical tool used for analysis of form, defined by size and shape through the different methods, including landmarks, data processed by process superimposition. So I learned this method from the Professor Klingenberg from the Manchester. He create the software that you call Morpho-J that create the geometric morphometric analysis. So we found that this is first time I went to the Spain 2 times, first to learn about 2D geometric morphometry. So interestingly, this is all the biologists, me and my supervisor, Prof. Farida, is from forensic pathology. But others, they learn the study of the shape of a flower. This is from Brazil, and this from Iceland. And this girl study about the shape of tulang ikan, fish. And this girl study about the crocodile, and this is a girl from the Poland. I think she learned other biology structure. And this girl is study about the rock, the batu, size of the batu. So all this person is a biologist, study different shape of the things. So we the person that study human. This is they study chimpanzee and all other animals or plants. So when I went this one, he said that, oh, this is a 2D geometric morphometry course. I said my data is 3D. He said that, oh, you need to come again and learn another course. So this is a summer during the June. Yeah. So I said, so I need to invest another 10,000 to come to the another course on winter. So I did I learn again 3D geometric morphometry. This time from US, the same place. Professor Dr. Melissa from US. So we learned, this time I went with the PhD student, Dr. Hanum. So we learned 3D geometric morphometry. So others also learn many things from the engineering and also other part. So what is the difference between geometric morphometry and also the caliper? Usually we measure the caliber, the bones by the caliber or digital measurement. But this one, many structure we not cover. For example, the corner, the sharp thing, the curve. But in geometric morphometry analysis, we can analyze every corner. Even though we found the fragmented bone, we can also analyze the fragmented, and we can narrow down the part belongs to which sex, male or female, and so on. So this is used for forensic anthropology, but also can use for any shape, any parts or any organ. So this is the difference between calipers and also coordinate. So it's a poor inter-rater repeatability, inter-raterability, and this one is a better validity and reliability, greater reproducibility, low standard error of mean, and limitation of the visualization of shape. We come with the mean, significantly difference or not, and standard deviation and so on, but we not come with the shape. But the geometric morphometry analysis, we come out with the shape, shape variation of individual things. So we have 2D and also 3D. So what is the difference between 2D and 3D? The 2D cover the length and the height, but the 3D cover the length, height, and also depth. So both 2D and 3D we do for research. So what we get from this bone, we can know whether the bone belongs to Mongoloid, Negroid, or Caucasoid. We know that the bone belongs for female and male. But in the case of too many things, sometimes female be a male and male be the female. Because this is a very subjective. Sometimes female, male like female, female like a male. So we need to have a system. They are very objectivity, like a software or database that can not interfere by the experience of others. So we need a system like geometric morphometric analysis, come out with a shape analysis. So the bones also can differentiate between this is a 6 months use old baby skull, and this is a mixed dentitions. Children and adult, then this is elderly. We can see what the difference between the baby and also the elderly. And this frontally was not fused, and this is fused already. So we also can differentiate whether this is a human or animal. Sometimes the forensic case found the cats or other monkey bones, not a human. So previous researchers have done in many parts, mental formants, coronal process, craniums, mastoids. And then my friends that had done it in the pubic bones, and then Dr. Mastura Maliza and in Scapula, they already done their PhD. And then my students do in the cervical bone. And then my friends do the upper limb and lower limb. And also I want to show the research finding that my PhD project last 4 years. So we want to know the morphology, investigate the morphology variation in the mandible of the Malay, Chinese, and Indians in different age group. What we did, we take 447 mandibles from the 2 parts from the forensic department of HKL and also from the radiologist department from HKM. And then we did the geometric morphometric analysis for come with the shape of the mandible. So we use a few software for landmarking. We did a Strasbourg checkpoint, and this is a bayar software yang dibeli, and this is free. And then we run the geometric morphometric analysis with multiple advanced size and shape analysis, and we come out with the visualization of the shape of the variation of the mandible. So at the end, we know whether this can come with the sex, female or female, ancestry, and also age. So the first step is I put the 27 landmarks, 34 landmarks in the central, and also 20 landmarks at the lateral, left and right side of the mandible. And then I run the software in the morphology, and we do a few analyses, general focuses analysis when the translation, rotation, and scaling was removed. And then we did, we found that the blue dot is a mean, and the black dot represent all the 447 data. And then we found that this is the percentage of variations of the mandible. We found that we have 40% of PC1, principal component analysis 1, is accounted of 16.9% of the shape of the mandible in Malaysia. PC2 is 13%, and PC3 is 9%. So we come out with the shape. This is a mean shape. And after the IDAV, we found this is the changes of the shape of the mean. And this is the male and female mean shape. This is a female and the male. And this is a Chinese, Indian, and Malay mean shape. And also we have a variation of this one. And this is the middle, young, and elderly shape of the mandible. So we found, we ran the MANOVA, we found that the ancestry have a significantly difference, and we can see that the highest significantly different between the Chinese and also the Indian. And we also run the age MANOVA, we found that the young and elderly have a highest significantly difference, and also sex also have a significantly difference. For the Procassus ANOVA, we found the sex is the highest size difference, while the ancestry age have a highest shape effect. So in the canonical variant analysis, we found that the Malay shape is at the center, while the Indians and the Chinese at the right and the left side. And we found that the most, and the dot represent one person. The dots, the highest significant difference is between Indian and also the Chinese, with the highest Mahala Nobis distance. So the age also, we can see the middle age at the center, and the highest significant difference between elderly and the young adult. Young adults. So we did a discriminant function analysis to see the either whether this one can discriminate between the groups. When we ran the sex, we found that the female can differentiate from the male about 80.3%, and after we did 1,000 permutation cross validation, the mandible can differentiate the female 75.8% and male 86.9%, with 83.6% after cross validation. So when we compare with sex, ancestry, and age, we found that the sex almost 80%. The mandible can differentiate between male and female, while the ancestry is 50 to 70% as a Malay in the center. Chinese and Indians is around 50 to 70%, depend on the ancestry. And the age also 30 to 70%, with the young age can differentiate highest in others' age. So in conclusion, we found that this project has compiled an extensive population database derived from multiple lemma of the CT scan of mandible, and no study have done before for compile such database and focus on mandible. And from unknown mandible, we could identify the identification of the person by using the above method. So what we did, this is unknown skeletal remains. We take it from the forensic department at UKM, and then we run with the same method, the CT scan, and then we go to our database and we run the geometric morphometry and found that this is a male Indians, and the age of the person is around 40 to 60. So we won a few awards. And this is my students did the same thing, but in the 2D, they put in the 400 data of the lateral calf, the same thing, and run the geometric morphometric analysis to find whether the patient is class 1, class 2, or 3, for the purpose of clinical of the dentistry. So, and then we did a few, because this is new, we are one of the pioneer after Dr. Helmi that bring the geometric morphometric things into Malaysia. So we did a conventional geometric morphometric course to share to the others. And we also did one book with the Dr. Zulkifli Al-Bakri, with our Prof. And we share with the RTM to the society. And we also did a few workshops to share to others. So what happened in the orthodontics, we also try to make it more simple. So if you do the, whether the patient have a class 1, class 2 or 3, it's quite a few days or week to know the final diagnosis. But in our data, we just go to our database, and the patient can know whether the patient is class 1, class 2 or class 3. This is the 2D landmarking did by my student. They put how many landmarks? I don't remember. And then after putting the landmark, they send to the notepad, and then they compile in a notepad plus before they send to the Morphogy for further analysis. So this is the things that we did. So we can see the outlier and view across the software. And within the few minutes, we can get the results. And then we won a few medals in many competitions. And then this is the latest one, you got a gold medal in your ITM. And I thanks to all my wishes, Sifu, this Prof Farida and Dr. Helmi that teach me geometric morphometric Malaysia, Prof Nuria. This is my professor here, Dr. Prof Emeritus, Dr. Patrick, Dr. Yannick, Dr. Farida Hussain that teach me from a master. Prof Kalinjebak that teach me the geometric morphometric. Prof Srijit that teach me how to do faster and many in one time. And Prof Melissa from US and also from Spain. So I would like to thank also my research partner, Dr. Choi, Dr. Masaran, Eric Ung, Kumastura, from a few university, USM, UITM. And also this is my students from UITM, also my partner, Dr. Naraina, Dr. Nagatamana. We also collaborate with the UTM for AI feature with Dr. Azuria to form a software. Because we can do this, but the technology part is for IT department, so we need to collaborate to others. So this is the PhD student that now run tengah create the software. And then Alhamdulillah, within the 4 years, we managed to graduated one to graduate master student, one going for ongoing PhD student, for 6 graduated degree students, and running also my students, one of my students, and also Dr. Hanim, and then Kumastura Faiz already graduated. So we also have a collaboration with UCIM, UITM, also UTM, and we patent and we did a copyright. And then this is around 26 publication of GGM and traditional method. We did a publishing mental foramen, crania, lower limb, mastoid process, cornet process, roll of hand and foot, upper limb, mandible, supraorbital, metacarpal, human skull, mandible malocclusions, cervical, facial muscles, facial hard tissue, soft tissue, frontal sinus, mandibular canine, cervical vertebra, crania, palatal rugae, bite marks, golden angle, dental edge, and a few others. So Alhamdulillah, this is the things that I want to share, that my thesis combined with my partner, Dr. Abdel Nasir, because I did in mandible, my friends did in crania. So you combine it as a scar. So this is a thesis change to book. So the thesis we combine and change to book, and then is whole is memang focus too many reference here. So we won buku ilmiah terbaik in science and technology from the few hundred books, and then we won. Alhamdulillah. So your thesis also can change to book. So we won it this year. So we get 1,000 ringgit, I think. And Alhamdulillah also be one of the got a award during the PhD and give a speech during the holding ceremony. And also selected as a adjunct professor University Airlangga last year, and this year dia lantik lagi. Alhamdulillah. And now I am a postdoc researcher at the Q11 for 1 year in the forensic odontology and radiology, focus on estimation from the T and OPG and CBCT. So I just so that whoever of you kalau nak sambung belajar pergilah Europe because it's very interesting. Within 1 year, I managed to visit 28 countries in Europe because the Belgium is at the center of the Europe. Esok nak pergi London 2 jam je. So France pun 2 jam. It's very sebelah-sebelah saja. So rugi tak pergi. So I managed to travel 28 countries in Europe during postdoc in Belgium with my family. So lastly, Abu Hurairah said that whoever alleviate the needs of needy person, Allah will alleviate the needs in the world and hereafter. Maknanya kalau kita bantu orang, banyak bantu orang, Allah akan bantu kita dalam apa jua apa yang kita lakukan. So this is pesanan penaja untuk attendance and also MAA PD point. That's all for laju my presentation today.
Thank you very much. Thank you very much, Dr. Aspalilah. It's a very great pleasure to see your journey in the geometric morphometric analysis. My mastermate, but I'm very proud to see your wonderful journey and how much you achieve in this field. And now she is also my supervisor for my PhD. Thank you very much for the great talk. So now it's the time for the Q&A session. So I would like, it's open to the audience. You can ask the questions or can put the questions in the chat box.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Dr. Aspalilah, thank you so much for accepting our invitation, and I would like to congratulate you for your superb achievement. Okay, you have so many students, graduated students, and I think that's really great. Okay, I think this is a very eye-opening, I would say, area in anatomical sciences, especially for the young anatomies. And I have 2 questions here. What if for the anatomists out there who would like to venture, for young anatomists who would like to venture in this area, you know, do they need to, I mean, is this kind of program is offered in Malaysia, and the software that you mentioned just now, is it available freely in Malaysia if they want to I mean, they want to continue PhD in Malaysia, for example? I believe you have many students, but I don't know whether you are collaborating with the UK collaborators. And then I just wondering about this geometrical analysis. Instead of just measuring it morphometrically, is there any other method to like investigate or to explore the defect or anything like changes in the morphology due to stressors or anything in the environment? Is there any way to investigate that? For example, like if you can integrate it with finite element analysis rather than just using this morphometrical analysis. I don't know. That is just I'm thinking out loud. Just wondering if you can comment about this. Thank you.
That's why we have in geometric morphometry, what we have is a shape, a shape. Last time in traditional method, we come with the mean and then standard deviation, discriminant function, regression analysis, all this number. So what is the next step is the shape. So we come with the shape. So the next step is AI. Is AI. It means that we need a computer science expert to come out with our project, and they will come up with the software. There is their specialty. Our specialty is study this one and come out with why there's the male and female difference. Maybe for many, for example, maybe the male eat more rush, or why Malay, Chinese, and Indian is different. Maybe the eat. Maybe we need to know the factors that cause the changes. But to come up with the things, we need other specialty, like that I now is a student PhD in I think ITM, and also you UTM now run the project. We also have a research with the UTM that compare the cancer and non-cancer, normal and normal things. So now they run things like that. I think that's all I can comment on it.
Thank you, Dr. Aspa. Just want to share something like there's another method, call it finite element analysis method, which is usually used by the engineering. Maybe I think this is a very good way to link between your expertise with the engineering expertise. You know, because this finite element analysis also can it can actually investigate what had happened previously, or we can also predict in the future, in something like that. I'm not very familiar with that kind of study, but this is what we had in our department. We collaborate with engineering, but I think it's very I would say you can collaborate with this area to expand your area. I don't know, maybe, I don't know. Okay, thank you so much for your response. Okay.
Thank you very much, Dr. Siti. Any other questions from audience? So Dr. Aspa, I have one private message from here. There is a question. The question is about, they're asking, so other than the forensic identifications, this geometric morphometry, one of the contribution is in the forensic anthropology to identify the unknown human. So other than that, how this geometric morphometry can help in the other field, other than the identifications of the unknown human body?
Okay, I try with my patient. For that, as I said, we can also do on case. For my case is orthodontics. What we did is we put the landmarks on the lateral calf for the class 1, class 2, and class 3. For the mark occlusion, where the patient is class 1, class 2, class 3, for the orthodontic treatment, nak letak braces, dia jongang ke gigi dia ke depan ke tu. So from that, we can know the shape. So anything that maybe for the future, or the whether the cancer or whatever, that's why we need to have a data yang normal dan data yang abnormal, to have the good database that can represent or come up with the mean of these types of group. For example, as I said, class 1 is normal, class 2 jongang, dia ada group dan bentuk dia. Class 3 is ke depan sikit, dia ada bentuk dia sekarang. So bila kita classify this group, so we can make our clinical part more faster. without any impression or take time to analyze the data. So the reason we did the research to simplify, or we did the research untuk memudahkan. So we can explore, initiate things that can help others, insyaAllah. Maybe in medical also ada normal or abnormal shape, whatever disease we can explore. That's all my comment.
Thank you, Dr. Aspa. Any other questions from the audience? Anything to ask?
I think we have also here Dr. Normaliza Abdul Malik, and also Dr. Choi, Dr. Fuad. They also did this type of research, so they also can answer. Maybe can help me.
So please do welcome to the other Dr. Fuad, Dr. Normaliza, if there is any opinion regarding this research field.
Dr. Choi also, Dr. Choi Kowun.
Dr. Choi is here. Okay, so I think there is no more questions from the audience. So I would like to express my heartiest gratitude to our guest speaker today, Associate Professor Dr. Aspalilah, on behalf of the MAA for your time, and also wonderful yet the comprehensive remarks regarding the geometric morphometric. We hope that this session has been fruitful and engaging as well, provided everyone the opportunities to gain the insight and also the knowledge in the geometric morphometric field. Okay, so it's good news to all the MA members. So besides this, you also could also grab this golden opportunity to become our inspirational speaker in the next session. So step forward to share your research with us via the link given in the chat box. So you can also become our speaker in the next session. So without next is our photography sessions. So I would like to request all the participants to turn on your camera so we can have one click before we end our session today.
Assalamualaikum and good morning everyone. So for this photo session, I would like to invite you to switch on the video so that we can make together photo session. Okay, I will count. Okay, are you ready? Yes. Okay, please smile. Okay, 1, 2, 3, smile. Okay, I think okay. Another one more. 1, 2, 3, smile. Okay, thank you everyone for your cooperation.
Okay, thank you very much. Ladies and gentlemen, on the behalf of the MAA, we would like to express our heartfelt appreciations for your contribution and active participation today. And have a great rest of your day. Have a great weekend. See you in the next round of the webinar. And I am Rani Sakaran, okay, signing off for today's event. Thank you very much. See you all in next event. Bye.